So on Objective 2 of Section 4.2, we're going to start talking about the slope and the y-intercept. So we're getting into a little bit of algebra. We're used to that y equals mx plus b. Let me write that on here. Y equals mx plus b. Where the n, the coefficient for your x variable, is your slope. And then the b is your y-intercept. That's always when x is 0. So we're just going back to some algebra there, all right? So just to kind of keep in mind, not a whole lot's going on here with examples other than just stating what we know when your slope is positive, what we know when your slope is negative. If your slope is positive, that means it has that positive relationship where as your x increases, so as you move right on your horizontal axis, you're moving up. But if you move backwards, they're both going, basically they go in the same direction. When you increase, you increase. When you decrease, it's a positive relationship, okay? A negative relationship is the exact opposite. As your x increases by 1, you're plummeting, so your y is decreasing. And if you're on the low end of your x's, so if you're on your low end of your x's, you're at the high values of your y, it's a negative relationship, okay? So let's look at this one scenario here. It says a researcher studies the population, the y or response variable, in a town in each year, the x or predictor variable. To simplify the calculations, years are measured from 1900. So basically what we have is if you plug in an x value a year and do the math, you'll figure out what the population is at that point of the town, okay? But since 1900 and 2000s are getting so high up there, you don't want to have to plug in 1900 or 2000. They said just make 1900 like your 0. So this is like x equals 0. So for however many years after 1900 you are, that's the x value you're going to plug in. So the example they use here was, for example, if we want to know the population in 1955, we would plug in the x value of 55. It's 55 years past 1900. Today it's 2018. What would we plug in? 118, right? Because we're going into the 2000s there. Gotcha, right? So say someone put this data into their calculator and they came up with this line to show the relationship between population and the year. And they came up with y equals 300x plus 12,000. They want us to interpret the slope, all right? So a slope of 300 means for every year on average, the population increases by 300. We'll write that down and I'll kind of explain what it means. A slope of 300 means for every year on average, the population increases by 300. Do you remember slope was rise over run? Do you remember that from back in the day? Or change in y versus change in x? The delta symbols there, you see that in like chemistry. What they're doing is they're making your run or your change in x always be an increase of 1. Okay, so like each year passes. So for every year, so that's your change in x. And then your y value is just doing whatever your slope was. Okay, so since that was a positive, that's why it's increasing. Since it's 300, it's increasing by 300. If that was a slope of negative 300, what would that mean? For every year, what's happening to our population? It would be decreasing by 300, okay? So problem after problem after problem on 4.2, they're going to have you interpret the slope. And remember, it's always your x value increases by 1. Your y value is doing whatever your slope is, okay? So as your x value increases by 1, your y value is doing whatever the slope is doing. Go ahead and toss it over to the top of page 7. Let's talk about the y-intercept. Oh, it's way up there. I was way off, okay? So the y-intercept is exactly that. It's where we cross the y-axis. You remember doing y-intercepts in algebra? Okay? It's where you cross the y-axis. No matter where you cross the y-axis, what is your x value always? 0. So your your y-intercept is always when x equals 0. Why do I keep pointing that out? Because think about it in terms of your problem. If your x value is 0, then your y, or whatever that y variable is exactly that. So let's look at this. It says, sometimes an interpretation can happen and sometimes not. if 0 is a reasonable value for x to plug in, then b can be interpreted, and it's whatever the value of that y is. If 0 is not reasonable, then we just say it's not appropriate to interpret. All right, so I'm going to write that model again. It's right here. Y equals 300x plus 12,000. This part's our y-intercept, okay, so that's why we're interpreting it. All you do, guys, is just say an intercept of 12,000 means in the year 0, but what was year 0? What was our baseline year, do you remember? 1900. The town's population is what? The 12,000. All right, so I know it's kind of awkward at first. It just says an interpretation of 12,000 means in the year 0 or in year 1900, the town's population is 12,000. It's just that baseline. It's that starting amount, okay? We haven't increased x at all. We're just starting at x equals 0. And obviously, year after year, that increase is going to go up. So remember, if x is appropriate to interpret, it's just what is your y when x is 0. Sometimes they're not. If you guys have started on your homework, one is like gas mileage. No, it's the weight of your car is the x variable, how much your car weighs, and the y variable is your gas mileage, because supposedly smaller cars have better gas mileage. And don't you guys agree with that? Like those little Toyota Priuses have way better gas mileage than, I don't know, Lincoln Navigators or whatever, okay? So, could you interpret the y-intercept in that problem? No, because what was x? It was the weight of your car. Can your car weigh 0 pounds? No. Okay, I think like 5 of you are listening to me right now. Okay, so your car can't weigh 0 pounds, and so x cannot be 0, so you would just say not appropriate to interpret your y-intercept. Another one is baby's head circumference to their length of the body, okay? So supposedly kids with bigger heads are taller or whatever it may be. But can a kid's head circumference be 0 inches? No, so that would be not appropriate to interpret. But you might have a linear model that is the number of hours you study for the test and what grade you get on the test. Can you study 0 hours for a test? Yeah. Yes. So that y-intercept would be whatever grade you're supposed to get if you studied 0 hours, all right? So let's make this make sense with our example that keeps coming back to haunt us, okay? I'm going to grab it. It is the one for the data of the golf club, okay? So I'm going to grab it. It's just from page 6. Y equals 3.2x minus 55.8, okay? Let's keep in mind our x variable is the club speed in miles per hour, and our y was the distance in yards. They want us to interpret both the slope and the y-intercept. Okay? They want us to interpret both the slope and the y-intercept. Keep in mind, slope is just as your x increases by 1, your y value is doing whatever your slope is. And then your y-intercept, so this is, rise over run, dy over dx, and then this is y when x equals 0. Kind of just keeping in mind what each of these are. All right, let's do our slope. First of all, in this equation, which part is the slope? The 3.2. Your slope's always in front of your variable, okay? So that's the slope. So what does a slope of 3.2 mean? Well, if you go back to the problem on the bottom of page 6, it was as your x value increases by 1. So what's our x value? Club speed. So as our club speed increases by 1 mile per hour, our y value, distance, is doing what? Increasing by 3.2 yards, okay? So as club speed increases by 1 mile per hour, the distance of the ball increases 3.2 yards. And again, it's just that x is increasing by 1. So club speed was our x, so x is increasing by 1. Your y value, distance, is doing whatever the slope is. So since the slope was positive 3.2, so basically if you go from 100 to 101 miles per hour, you'd expect a 3.2 yard extension to that drive. Are there any questions there? The more you get into it, you'll see what's nice, guys, is you don't have to type these up on your own. It's just going to be multiple choice, okay? You will have to write it like this on a worksheet and on the test, though. So make sure you feel comfortable. Come to me if you have questions, okay? The y-intercept is always when x is 0, okay? So, in this problem, what is x, your club speed? So if x was 0, we're swinging our club 0 miles per hour, our golf ball should travel negative 55.8 yards. Does any of that make sense? No. First of all, your golf ball shouldn't travel at all if you're swinging at 0 miles per hour. And secondly, I don't know what a distance of negative means. They go backwards, okay? So this would be an instance where you would choose not appropriate to interpret. I'm still going to interpret it so you can kind of get in the habit of seeing what you should say. But after we write it and you realize it makes no sense at all, that's when you say it's not appropriate, right? So if club speed is 0 miles per hour, the ball's distance is negative 55.8 yards. And then you would say not appropriate to interpret. If your x is 0, the y is the y-intercept. In this case, x was club speed, so if our club speed was 0, the y, in this case the distance, is whatever your y-intercept is. If you do that and it doesn't make sense, just put not appropriate to interpret. All right, compute the sum of squared residuals. Some of you might have seen that term when you were working on 4.2 homework. We will come back to this, okay? We'll come back to this at the end of class today because I have a worksheet, okay? So we'll come back to it. Basically, guys, this is just the proof that the least squares regression line is the best line, okay? So if someone tries to be a smart aleck and says my line is better, you would compute the sum of the squared residuals for their line, you would compute it for the least squares regression line, and the sum's always smaller with the least squares regression line. We want to minimize that error. That's 4.2.